Everybody, it's Tyler here at Fit Waco, checking team number 2881 Lady Cans. Lady Cans this year, absolutely phenomenal robot with their suction intake that they have that's really effective. We're going to be covering through a full robot process on this, including their arm, the suction, and got a cool little buddy assist climb I can't wait to tell you more about, and some programming. Let's talk more about Lady Cans coming up here on Behind the Bumpers. This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the World Championship. Go to kettering.edu/first to see locations you can meet a Kettering University representative. The Charged Up competition season is here. We have a ton of live Twitch and YouTube content coming to you. All of our uploads and archives, including shows, behind the bumpers, Finalysis, and more, are available at youtube.com/firstupdatesnow. Check out all of our live shows on Mondays and Tuesdays at twitch.tv/firstupdatesnow. So Zosha, let's talk about the suction on your robot. Looking at suction on here, a previous team that we interviewed had like 5 suction cups on it. Your team has 2, and we were talking earlier, I was really enamored to hear about how you go about that process of getting the suction to work, how things are separate, that sort of thing. So talk to me about what's gone into it and how it's worked out for your team.
So like you said, we have 2 suction cups, but they're run by an individual motor each. So each suction cup has its own motor, and that allows us to get more like suction per suction cup, so it's not like one divided over 2 section. So if you want to raise the arm up a little bit. We decided on 2 and in this orientation because it works easiest for picking up both the cone and the cube. Sure. So for the cone, we can just sort of grab near the base, and it'll turn off automatically when we have suction. And it's smart, so like it knows if it loses suction, it'll turn on again until we grab suction. And it'll turn on just the motor that lost suction. All right, I gotta do a test here and see how, that's pretty well on there, holy cow. So yeah. That's really neat. When you were looking at testing, how did you come up with that 2 was the right number versus like other teams we're seeing that have like a lot more? Well, to be honest, we bought 2 to start with. Yeah. And we just sort of stuck with it. We did testing. We did what you just did and tugged on it, and it stayed on there pretty well. And so we decided just to stick with 2. Looking at cones versus cubes on there, did you have to take your approach differently for the cones versus cubes, or were they pretty much interacting the same way with your suction? Yeah, we had to take our approach a little bit differently. Cones are much easier to pick up because they're not as squishy as the cubes. Cubes, if they're a little bit under-deflated, sometimes it wrinkles instead of like just getting a good suction. But we've still been able to get a good suction on both the cones and the cubes. When you're looking at picking up, are you mostly from the station areas, or are you picking up from the ground as well? We can do both. We prefer the station areas just because it's faster than the ground. Sometimes it's a little bit hard to line up, but we can do both. Lastly, from a suction in general, when you were first looking at the game, what made you choose suction in the first place versus some of the other claw intakes that we've seen? Well, so when we were in our prototyping phase, we tried both like a claw and suction. We actually had a claw from an off-season that we can modify pretty easily to pick up the game pieces. But so we knew we could do a claw, but we decided we wanted to try suction in our prototypes just to see if it would work. And it worked out pretty well, so we just decided to go with it instead of a claw. Yeah, let's move into the arm next and talk to me about, huge lead screw that I see right here as it goes through on that, but I'd love to hear more about that and how you actually deploy and score the game pieces as well.
Yes. For our arm, we have 2 lead screws. One lead screw moves the arm up and down, and the second lead screw extends the arm. It's a telescoping arm, so it extends and comes back. So it's actually like inside of here? Yes. Oh, that's really cool. Inside of there. Yeah. We have a Neo 550 that spins spins the screws for it to extend, and then we have a regular Neo to just move the arm up and down.
When you're looking at from the overall tower structure that you're doing on this, how did that design process go where you're like, hey, this is kind of the route that we want to go? Like, what came first? Did the suction come first or the tower, that sort of thing?
The tower definitely came first.
Okay.
Because we realized our arm needed a lot more stability. So we had this tower originally, but then the tower wasn't really working out, so then we just added these extra poles for stability, so it would move the arm from our robot.
And then lastly, from the telescoping, I haven't seen too many teams do like a lead screw as the telescope itself. So from a design process that you were doing, how did you come up with this and how did you determine that's best for your team?
So last year's robot, we used lead screws and we saw that it was basically the same thing. So we just copied and pasted it twice and made our way through it and looked what worked and looked what didn't. And we added and modified as we went along through prototyping.
That's really cool. I love to hear about those iterations and processes you go through. Erica, next we're going to talk about the buddy climb that you have that you're looking to do. This is a little bit different than some of the other teams that I've seen that are attempting to do something similar like this. So I think you call it Buddy Assist, if I remember correctly. Talk to me about what it is and how'd you come up with it?
Yes, so this, unlike other designs, allows us to work with our teammates to go up the charging station. And so they each run individually of each other, which means we can grab onto one robot, slide over and grab onto the other, or just grab onto one if we want to. And it rotates down. Yep, that one. Like that. And essentially cinches onto our opponent's frame and then can move back up if we want to release. But it stays in this position so we can drive up the charging station with our teammates.
So are you hanging off the charging station then, or how does that, like, how is your robot position in regards to the charging station?
So depending on if we have one robot or two next to us, we can center ourselves or be slightly to the left or right.
How did you do testing for this to figure out that this was going to work out for your team?
So we attached a similar mechanism to our off-season robot with Swerve and clamped onto our last year's competition bot and drove down a hallway, and it worked incredibly well.
Last thing I ask, if we can see that come out one more time, as this kind of like cammed over and locked in, how did you come up with doing that design for? That was kind of a cool aspect I saw as it came down.
Yes. So when it locks itself like that, that makes it harder to come off our teammate, and so they won't like slip as we're going up the charging station. And this was determined with some testing that this worked better than just having an arm because it was more likely to slip upward if we drive up at an angle.
This is definitely one of the more creative processes I've seen, so I can't wait to see when this becomes used on the field during your either quals or playoff matches. It would be very exciting to see for that. June, let's wrap up on your robot and talk about some of the programming features gone to. We'll show a couple things on screen as well too, and what's gone into this incredible robot that you have.
Yeah, so we've actually had a lot of various driver feedback things. So we have, as you can see, these two cameras that are on the left and right side of our robot, and they actually see April tags. So at the bottom here, this represents the grid. It is the cones and the cubes.
Yeah.
And if you had an April tag in front of it, based on the April tag, there would be a little robot that would show up and show you where you are in relation to those cones, the scoring. It really helps the driver score. And on the right side, you can see that is like a driver feedback for the suction. So the little dash circles show each individual suction, and then like that.
Can we put something on it? Let's see how that works.
Mm-hmm.
Oh, that's really cool. So if one were to come loose, and you would actually get that feedback on there too. How does that, like, what kind of sensors are determining that?
We have a sensor within the actual the tubing.
Sure.
That senses the PSI of that, and adjusts from there.
That's so cool. I just love to see everything that's gone into this robot. The full thought process seems really complete.
Yeah.
So I commend your team on that. And of course, Lady Cans wish you best of luck at this event, but of course in the future as well. Thank you so much for telling us about your team and your robot. This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the World Championship. Go to kettering.edu/first to see locations you can meet a Kettering University representative. The Charged Up competition season is here. We have a ton of live Twitch and YouTube content coming to you. All of our uploads and archives, including shows, behind the bumpers, Finalysis, and more, are available at youtube.com/firstupdatesnow. Check out all of our live shows on Mondays and Tuesdays at twitch.tv/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.